Welcome students to our very first module. And in this session, we'll talk about introduction to cloud computing. So the objectives of this session is that we'll talk about definition of cloud computing, followed by some essential characteristics. And then we will see how the cloud computing came into being. So let's start with defining what a cloud computing is. So what is a cloud first of all? A cloud refers to the form of servers which host various applications that run on them. The form of servers you can see as if they are servers. They are a group of servers which are sitting inside a data center. And what are they running? They are running various applications. They can be web applications, your database application and whatnot. So what is cloud computing now? Cloud computing is an on-demand delivery of compute power, database, storage, application and other IT resources. How they are delivered to us? They are delivered to us via internet. And there's a pricing model. How do we pay? And that pricing model is called pay as you go. So the key terms here to understand is that cloud computing is delivered to us on demand. That means, so just imagine, with the click of a button, the service or the computing power which we need is available to us. As soon as we are done with our computation, we can just turn it off. And we get this delivery of the computing power via internet because the data center resides probably elsewhere and we can only connect to the data center via internet. And just because this service is on demand, we pay only for what we actually use. Let's look at the formal definition by NIST, which is the National Institute of Standards and Technology. So they define cloud computing as if the cloud computing is a model for enabling ubiquitous, that means everywhere, convenient on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. So this definition seems complex, but there are so many things which they have actually summarized. So the keywords here to understand again is that it is on demand and it says a network access because it is delivered to us via internet, and they say a shared pool of resources because we as a customer, when we talk about cloud computing, so we share the resources, like one machine can be shared by multiple people here. So that's why we call share pool of configurable resources. And then as this service is delivered by on demand, so obviously if we want, we can rapidly, create some machines which are virtual machines on the cloud, and then we can release them when we don't want them. And everything is done with a minimal effort. So imagine just by click of a button, you can actually create a virtual machine and we can use it and then we can turn it off. Let's look at the 5 different essential characteristics. So these characteristics actually define how the cloud computing is. Definition talks about everything, but characteristics are pretty important. So the first one is on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Let's look at each one of them one by one. So on-demand self-service. So the provision computing resources. So we can actually create resources with a button click. So we don't even need a human interaction to get this done. Then this provisioning is automated. It is automated. You can just click some buttons to get this done, or you can actually program using APIs. The next thing is how do you control your deployed resources? And this is often done via the management console. And any cloud provider which is out there, they give you that management console where you can control how the applications work. So now you can adjust the usage of the service, but there is no need to renegotiate a contract. So in any cloud computing environment, there are no fixed contracts like you have to use this much of computing power. No, it's not like that. You can adjust what you want. If you want to use just a single machine, you can really use it. And if you want to use 100 machines and then just for let's say 1 hour and then just stop them, you can definitely do that. There is no binding on your contract. And the next thing is you pay only for the resources which you actually use, right? So this is all about on-demand self-serve. Next thing is broad network access. It's an important point or the important characteristics. First thing is it is a ubiquitous access. This service is available to us by internet. So we can access this service from anywhere we want to. And again, so when we say anywhere we want to, again, it's device agnostic. You can access those services on your mobile device, on your tablet, on your, like any computing resource you can use, which is device agnostic. You can access those services. And again, these services are built on interoperable standards. So they use some standard protocols, like their delivery of the services is done to us via HTTP, HTTPS, pretty standard protocols, so which are interoperable. So they operate pretty much easily with any of the devices or any of the machines which are out there. Now the platform is actually consistent regardless of the device or like whatever you use. The platform give you always the consistent service. So this definition or this key here is that the service which we are talking about is regardless of the platform you use. Again, like the same thing. If you are using a mobile device, the nature of the service will not change. So it will still be the same. Imagine, let's say you are using Netflix. So whether you are watching or viewing Netflix on your mobile app or your TV, so the service is not going to change. Then the next thing is location transparency. This is again key indicator here, that so wherever I access the service from, I will never be able to know where I'm getting the services from. So I may be sitting inside Europe, but I can access a server which is in, let's say in America. So which is location transparent. You will get a service which is delivered to you, but your location will still be transparent. That's also indicates the global nature of cloud. The next thing is again network dependent. It's very important because how the cloud computing power is delivered to us. It is delivered to us via internet. So that means having a high broadband connection is actually helpful because we are going to get everything delivered to us via internet. The next thing is resource pooling, because we talk about shared resources. The model which you follow at cloud is multi-tenant. So imagine you have a one big house. It has got multiple rooms. So people sharing those rooms, that is a kind of model we actually follow in a multi-tenant model in a cloud environment. And this is a beautiful thing because when we talk about cloud, we talk about cost savings. So now if we share the resources, definitely the services which we are using when we are sharing, because of sharing, the cost goes down. So next thing is dynamic allocation of resources. If I need just one machine right now, I have those machine which is available to me for my disposal. And if I want 100 machines, probably very easy for me to scale and get those 100 resources. The allocation is again dynamic and it is based on the demand. So if I want, if the demand right now for computation is just one machine, that it be, and if it goes beyond that's how I can provision. Now the pooling of resources, I discussed that we can have cost saving because we're sharing resources. These services can scale seamlessly. I can have one machine right now, I can have 100 machines in for next 1 hour and I can turn it off. They scale pretty seamlessly. It is a sublime operation, and the systems are efficiently managed. They're centrally managed, and the upgrades are done pretty centrally. The next thing is elasticity. So elasticity is actually a property of the cloud computing platform. So elasticity here, just think of a rubber band. You can stretch and you can give it back when it is needed. Similarly, you can stretch your services. You can do automatically scaling of your resources based on load. If the load increases, you can scale up your resources and you can decrease as you want to. Scaling here means you can increase the computing capacity. And this is instance within no time, within real time or very minimal delay, you can get your services provisioned to you. You can get your compute capacity available to you. The next thing is, again, it is flexible. You can adjust your services what you need. So it is pretty much flexible. There is no binding of the contract which we saw. And it is again cost effective because you don't have to provision a capacity beforehand. If you need a capacity for one server, if you just have the load for one server, you can provision one server. You don't have to pay for the additional 99 servers which you might have to, let's say, work on in the next 1 hour. And the perception here is that you have unlimited resources, even if you see like there are finite number of resources or computing power, which is actually sitting inside your data centers. The next thing is this service is measured. Why it is measured? Because we pay for what we use. So everything is measured. There's a metering which is there. You have a transparent billing and management of these services. Then just because you pay for your use, all the computing resources are measured. They might be measured. Some of the services are measured in hours. Some are measured in minutes, seconds, and sometimes you measure by the number of operations also. Then again, you can optimize the resources because we know like the demand is low. We can optimize the resources. We can reduce the capacity and then we can increase when we want to. Then everything is transparent because the services which we use, they are measured. So we can easily see if I use a system for 1 hour, I can see like I will be only paid for the system for 1 hour. And then we have the service level agreements, and this guarantee that the performance which we get out of it, it will be a quality service and the performance will never degrade. The next thing, let's look at the evolution of cloud computing. So how cloud computing came into being. So all this actually, started way back in 1950 when Professor John McAfee introduced the concept of utility computing. Back then, 1950, what he said, just like, we were using telephones in 1950. So he was saying when you make a call, you just pay for, the minutes or the bandwidth you consume for that particular call. So he predicted that back then that computing might somewhere down the line will be similar to utility computing. In 1960, we started looking at the concept of time sharing where, multiple systems, multiple terminals use a single host computer. So how do they share the computing resources? By time. So let's say every 5 seconds, the terminal goes and accesses the server, they get their computation done and then go back. They were accessing the system, one single system based on a time sharing system. So by 1970s, actually the concept now came for virtual machines where you have got a one big server and you can partition the server or the computing resources by virtualizing them. That is where the cloud computing was actually born. Right? So this virtual machines or the virtualization is actually the core principle here. Virtualization enables the hardware resources for a single computer, process, memory, storage, and all the other, network or hardware containing resources to be divided into multiple virtual computers called virtual machine. So this is the core principle. Like if somebody talks about cloud computing, what's the core principle of the backbone? That backbone is virtualization. Without virtualization, cloud computing is definitely not possible. Then let's see, who were the pioneers here. So the Salesforce in 1999, they actually offered delivering their enterprise application via internet. So Salesforce is an ERP software. So they started delivering their apps via internet. In 2002, Amazon came with the EC2, which is Elastic Cloud Computing System, which is nothing but a compute as a service. So imagine this is a virtual machine. They offered you can spin up your virtual machines back in 2002. And then Google in 2006 came up with Google App Engine. So our Gmail service or the Google Docs or whatnot. So they were offered as a software as a service. So with this, we are towards the end of this session. So what we have learned so far. So we have looked at the definition of cloud computing and we know that it is on demand. So it is delivered to us via internet. The pricing model we have is pay as you go. Then we look at the 5 different essential characteristics of cloud computing. So looking at them, you actually understand, at the breadth what cloud computing service is. Then we looked at the birth of cloud computing, how in 1950 we started with the coining of, the utility computing. Then 1960 we saw how the time sharing worked. And 1970 we saw actually the virtualization being created. So virtualization, as we discovered, it's a core principle of cloud computing. And then we looked at the pioneers of cloud computing during the inception era.